If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 165 to up to question number 170. Okay, then let's try to solve these 5 questions. Okay, in question number 166 what is asked, a 3-phase case induction motor is started by doll starter switching at rated voltage. If the starting current drawn is 6 times the full load current and the full load slip is 4%, the ratio of the starting torque developed to full load torque is approximately equal to. So starting torque and full load. So if you write the torque equation, so T is equal to 3 by 2 pi ns. Now let me write it, S into E2 square divided by R2 square plus S square x20 square. You can put it S square also, then you have to put this is R2 by S. This is actually I square, so it becomes your I2. That is full load current or whatever current it is taking. Now you have to be careful. Here we put generally NS, but we can put NR also if you take the output power. This NS is taken if you take the air gap power. That means net electrical power that is converted into mechanical part. But after that also there are some losses in the rotor and friction and windage loss. So if you take the output power, final output, then you can take this R. So T into omega R will be equal to final output. But if you are writing T into omega S, then it is not final output because it is not rotor speed. What is the formula for power? Torque into rotor speed. So torque into that is your final output. But if you are writing omega S, then it is not actually that power, it is actually air gap power. Why it is so? Because if you multiply by 1 minus S, then only you will get omega S. So if you multiply air gap by 1 minus S, then only you get air gap power. So in one of the questions we have used this one as omega R, I think in question number this one 162, because it was directly given P output 15 kilowatt. So this output was given, so we use that omega R. But normally we take omega S if you are given air gap power. So here this is your T. So T full load torque which will be equal to, this is full load, so 3 by 2 pi ns, and this is your I full load square into R2 by what is S, full load S is given 0.04. Now what is starting torque? At starting S is equal to 1. So again it will be 3 pi by ns into it will be I starting now. So I starting they have given 6 times the I full load. So it is I starting instead of this is I start will become, because you are writing for starting S is equal to 1. So this will become I start which is given 6 into I full load square into R2 by starting S is equal to 1. So this ratio they are asking, TST by T full load. So these are constant. So if you divide this by this, it will be 36, and if you divide this by this, it will be 0.04 will come as into. So it will be 1.44. That is your answer. Now if you come to 167, under V by F control of the induction motor, the maximum value of the developed torque remains constant over a wide range of speed in subsynchronous region. Subsynchronous region means the speed which is below synchronous speed. So this one is very standard, you know this one, because if you change V by F control, so due to F speed will change, but there will be no change in I2 because you are keeping that flux constant between these two, because your phi is directly proportional to V by F. If your phi remains constant, so your E2 remains constant. So your current that is taken from the secondary side, that also remain constant. NS is constant, R2 is constant. So what happens? This doesn't change. So your developed torque remains almost constant. So A is correct. So B, the magnetic flux maintained is almost constant. Yes, that we know because V by F will maintain, if you maintain that ratio V by F, because phi is directly proportional to V by F. So that is also true. So both A is true, both B is true, and B is the correct explanation of 1. Because phi is true, that's why secondary E2 is true. That's why I2 is constant. That's why your torque is constant. So that means both A and R are true, and R is the correct explanation of A. That is option A, 167A. Next, if you come to 168, the speed of a 3-phase 440 volt 50 Hz induction motor to be controlled over a wide range from 0 speed to 1.5 times the rated speed using a 3-phase voltage source inverter. This B by F will be constant. It is desired to keep the flux in the machine constant in the constant torque region by controlling the terminal voltage as the frequency changes. So you will change the terminal voltage. That is V by F control, the inverter output voltage versus frequency control. So because your torque should be constant, so your V by F that maintained should be constant. So that you have to keep constant. So if you are changing this one, So it will start linearly. If v by f, that slope, what will v by f, what is y by x, that is slope. So it should be constant slope. So it will be a straight line, linear straight line starting from 0. So it should start. But after some time it will not be constant. Why? Because if you go beyond 50 Hz, you cannot increase your rated voltage because you are taking supply voltage from 440. So your source that is feeding voltage is 440. So you cannot increase that voltage now more. So after that it becomes constant, flat. So beyond 50 Hz it is you cannot increase your supply voltage abruptly. So after that, therefore your voltage remain constant. So this zone becomes your field weakening zone, because if you can constantly increasing this f without changing v is flat. So this your phi will reduce. That is known as weakening field region. So that's why the graph will look like this. That is your option D. Next, if you come to 169, the speed of a 4-pole induction motor is controlled by varying the supply voltage while maintaining the ratio of the supply voltage to frequency constant as the rated frequency of 50 Hz and the rated voltage of 400 volt. If its speed is 440 at this much rated frequency and voltage, its speed is 1440. Find the speed of 30 Hz. If you apply 30 Hz, if the load torque is remaining constant. So if you are keeping your torque constant, so you can write the equation for torque. So T is equal to 3 by 2 by ns into s into E2 square by R2 square s square x20 square into R2. That is 3 into I square R. So if you want to include this frequency here, because you are changing frequency, so you change this ns into frequency also. So it will be 2 pi into 120 f by p, and then you see which are the variables. R2 square plus s square x20 square into R2. Let me calculate the E2 also. Initially this was 400 because you are keeping V by F constant, so 400 by 50 should be equal to this by 30. So let me see if you apply 30 Hz, then what is the voltage you are applying, because you are keeping V by F constant. So V1 by F1 should be equal to V2 by F2. So if it is initial case, it is 450. So if it is 30, then what it should be? So this should be equal to this into this 8. That means 240. So this one you know, the second case the voltage is this. Now you can see torque is, what is the proportional torque? Torque is inversely proportional to your F. So it will be F2 by F1. P is constant, all these are constant. And it is directly proportional to your E. So actually E2 is it's referring the rotor. And let me write it E dash by E double dash. It is directly proportional to E. And then it is because s is very small, so you can neglect this s square, so you can remove this s square, so it is directly proportional to s also, so it is s1 by s2. Now your torque is constant, so this is 1. So you can calculate what is the slip. If you know slip, you can calculate the speed also. So this is 1 because T1 T2 is equal to 1, and it is F2, that is T by 50 into, it is 240 by 400 square. S1 is given 1440. Let me calculate what is S1. Ns equal to 120 into 50 by, it is 4 pole, 1500. So your S is equal to 1500 minus 1440 divided by 1500. That is 4%, which is 0.04. So this is 0.04. You don't know this one. So if you calculate your S2, it will be 0.0666. That is 6.67%. Okay. Now what will be your new NS? It is not 1500 because your frequency is 30 now, divided by 40. Your new NR will be equal to 840 rpm. So that is your answer. That is option C. Now if you come to 170, a 3-phase 4-pole 400 volt 50 Hz star connected induction motor has the following circuit parameters: R1, R2 dash, X1, X2 dash, XM. The starting torque when the motor is started on doll using approximate equivalent circuit model. So if you go for approximation, this is actually R1, this is R2 dash. It is actually divided by S. At starting it is 1, so you can keep it R2 dash. This is X1, this is X1, X2 dash, and this is your XM. Okay, so what is the formula for starting torque? It is 3 by 2 pi ns into S is 1, so it will be E2 square by R2 square plus X2 square into R2 because S is 1. So 3 by 2 pi, what is ns? Ns you can easily calculate it, but this should be in radian per second. You have to be careful. It is 120 into F by 4. what you are calculating is in RPM. So it is 1500 RPM. So if you change it to RPS, so it will be 60 will be, because you multiply in 2 pi ns, so you are already converting into radian, and it is radian per minute actually, but you have to convert it in radian per second. That's why, because it is radian per second, and if you multiply by 2 pi, it is coming to radian only. So divide by 60, multiply by what is E2, are connected, you are giving 400 volts. So what will be E2? E2 is the per phase voltage that is getting, so it will be, because it is star connected, 400 is line to line, so E2 will be equal to 400 by root 3, because it is calculated per phase, that's why it is 3 into multiply. So you have to careful, you have to should be per phase. What is R2? What will be the total R in this circuit, equivalent circuit? This plus this, that will be the total resistance, that is 1.5 square. And what is X total? 1.2, 1.2, it will be 2.4 square multiplied by 0.5. So if you do this one, it will be 63.6 Newton meter. That is your option A. If you like the video, then press the like button and please give your valuable comments in the comment section.